So this is the first question. The question is on tensors. Now, for those of you who have not studied tensors, do not worry, do not get tensed. It is a very simple question. You will be able to solve it. And the question is, consider an antisymmetric tensor Pij with indices I and j running from 1 to 5. The number of independent components of the tensor is, we are given 4 options. Now, antisymmetric tensor means that if you have Pij is your antisymmetric tensor, so if you interchange the indices, so if you interchange, then you get a negative sign. Sorry. So Pij is negative of Pji. So if you interchange the indices, you get a negative sign. That is the antisymmetric tensor. Now, you can represent this Pij tensor as a matrix. And if it is an antisymmetric tensor, you can represent this as an antisymmetric matrix. So if I want to write the matrix representation, this would be by an antisymmetric matrix. So everyone would be aware of matrices, even if you are not aware of tensors, and that's how you can solve this question. So we are given that the indices run from 1 to 5. So it's a 5 cross 5 matrix representation that we will have. So let me write down the matrix representation. It will be like 5 cross 5. So 1, 2, 3, 4, 5. 5 rows and 5 columns. Okay, so this kind of a grid we will have. Okay, so this will be the 5 cross 5 matrix representation. And if it is so as someone has given the option and it is the correct option, we will just discuss it. So now if it is antisymmetric, then what we have is Pij is equal to minus Pji. Now this means that the diagonal terms, which are Pii, would be 0, because 0 is the only number which is like the negative of itself. If you have 5, then 5 is not equal to minus 5. Only 0 is equal to negative 0. So the diagonal elements would have to be 0. So each of these terms over here in the diagonal would be 0. And since it is antisymmetric, all these terms in the upper triangle would be negative of the terms in the lower triangle. So all we need to worry about in the terms of independent components are these upper triangular or equivalently the lower triangular elements, because the other triangle, so this thing right here, would be the negative of the upper triangle. So purple would be equivalent to negative of the green elements. So so we only need to consider one of the triangular elements. Now the independent components would then be, so we just need to consider these elements. Let me just highlight them for you. So these elements over here are the independent components. So you could simply count them as well, but we would let us just write down the general expression. So independent components would be given by n squared minus n divided by 2. And why so? Because n squared are the total components. So if the indices run from 1 to n, say, then n squared would be the total components and n would be the diagonal components. And diagonal we know is going to be 0. So n squared minus n by 2, and n in our case is 5. So n squared minus n by 2 for n equal to 5 is 25 minus 5 by 2, which is 10. So as Priyanka and Rajiv have correctly answered, the option is B, 10. So this is how you will solve the question.